I'm going to go into the scanner icon here, and I'm going to go into the enhanced side or the manufacturer side of the scan tool. That is one of the tests. So when we talk about bidirectional control tests, this is allowing me to use the scan tool to help me do the tests. So system tests are more comprehensive. So in this case, I have a system test automatic. I also have a system test manual. So the manual test allows me to go through the different steps with the factory service procedure and look at different pressure readings and see what happens. Or I can use the automatic test on this vehicle, and it'll actually run my fuel evaporation monitor and set a code if something's not right. So here it tells me everything it activates. It activates my purge valve, my vent valve, and my vacuum pump in order to test the system. It says to prevent damage, it'll stop it if it gets too much vacuum, and it tells me it don't operate for more than 15 minutes. So it tells me to put the vehicle in park, ignition on, not running, fuel temperature below 95 degrees, and the fuel level must be between 1/2 and 9/10 in order for me to be able to run the test. Ensure fuel levels between that capacity. If fuel level is too low, test will take longer to build the required vacuum and might fail. So it's giving me a warning here. So we're looking at very specific enable criteria for me to run the test with the bidirectional controls. This is going to be different enable criteria than what the vehicle will be looking for when it runs the monitor on its own. And we would have to go to the service manual to look up that enable criteria. So I'm going to click OK here. Want it to continue. Ensure the engine is not running. Yep, continue. And I can use a graphic display, digital test display. So let's go to a graphic display. We love pictures. So this is telling me I only get one shot at this per key cycle. So if it doesn't work, I'll need to turn it off, turn the key off for usually 10 to 30 seconds, and then I can try again. EVAP system will simulate the system monitor. If a malfunction is detected, a diagnostic trouble code will be set. We'll begin the automatic test. Test will take 8 to 20 minutes. So this is a test I can let it do, walk away from, and see if it's successful. Remember, because it's running the actual test, it'll set mode 6 data, and it will complete my monitor. Not all cars will do this. This is something unique to Toyota, but other manufacturers will do this also, and more cars are doing it. So here I'm looking at whether my vacuum pump turns on and off, whether my vent valve is on or off, my EVAP purge, my vapor purge, and my pressure change. So this is all the components we'd use in our fuel evap system in order to run the monitor. So I use a vacuum pump here instead of engine vacuum. My purge solenoid is my front door, my vent solenoid is my back door, and we have a pressure sensor in there that's going to what? Measure the amount of vacuum or pressure I put in the fuel tank. So right now it's checking to make sure that I'm close enough to atmospheric pressure to start the test. If I already have too much vacuum or too much pressure, it won't let me run it. Vacuum pump came on. We saw a drop in vacuum. My vent valve is still open because it's turned off. So it's only going to pull the vacuum so far. So this tells me that my vent valve is not plugged, because if it was plugged, it would go down lower. The computer already knows what those magic numbers are, and it's going to be able to tell when the vent valve closes. It also proves that my vacuum pump works. If you listen carefully, you may be able to hear the pump running. This system will normally run when you shut the car off, and it's been shut off for about 5 hours. So if you come out in the middle of the night and you hear a buzzing noise under your car, it could be your vacuum pump running an EVAP test. So this is gauge pressure, this is absolute pressure. That's why you see the differences there. Okay, so if we look, the vent solenoid just turned on. When it turned on, we now have a change in pressure. So we lost vacuum for a second because we changed how we're flowing vacuum. I'm going to pull vacuum back down. So it established a baseline. Now we're going through, we closed our vent valve. We want to see this come back down. The nice thing about graphing it is you can see the relationship here. So if this switched, but this didn't change, then we know this isn't working. So that's the advantage we have over graphing our data compared to just looking at it in a digital form, is seeing these relationships between different parameters or PIDs. And the computer, since it's a clock, knows it needs to get from here to back down within a certain period of time. If it takes too long, it must have a leak. It knows how much fuel is in the tank. It knows how long it should take to get there. Someone a lot smarter than me has already done all that math, and it's programmed in the computer. And we can see now we've just gone down lower than we were here. You see that number climbing. Okay, what happened? We just opened the purge valve. When we open the purge valve of my front door, now what happens? I'm pulling air in through the purge valve, so we change. We close the purge valve, turn this off, drop back down. So I can see the relationship between when I'm open and closing these valves to what happens with the pressure, and my pump just turned off. So I can see all of that happen, and I can see that it passed. So that's what a good one looks like. And it also kind of helps us walk through how a fuel evaporation test works on this system. And again, it's all about, as I open and close doors or turn the pump on and off, am I getting a pressure change? So by graphing multiple PIDs, I can see that. Now I click continue. The next step would be display any codes. So now we're going to go in and check for codes. And if I want to look for pending codes, I have no codes present, which means that we passed this last time. I can also check current codes, no codes present. So I have not set a code, which means that I passed. So now from here, I can back out of this, perform my repairs, and back out again, get back to a main menu here, and I can get into generic functions. I can come down to mode 6. And now I can come down to my purge flow monitor, which is my fuel evaporation system. So let me click here. And you can see now, instead of having 3 zeros, I actually have real numbers. And I've run quite a few tests. You can see this last test was not run. It still has default values in it. However, if I look at the top, it tells me all these that have passed. So now let me return out of here, and let's look at our monitor status. Remember before we only had 3 monitors complete, our 3 continuous monitors. Now if I look at fuel evaporation system, fuel evaporation is complete. So this tells us a couple things. First of all, that the scan tool is able to complete the monitor, so I don't need to drive the car away. Which means that if I had a code set by the monitor, I've just proved I fixed the problem. That's huge. The other thing it does is it shows me that especially on the fuel evaporation system, all the tests don't have to be run to complete the monitor. So for example, maybe one of those tests is to test for a big leak and another test is to test for a small leak. If I pass the small leak test, do I really need to run the big leak test? Because if I prove that we don't have a leak that's 20 thousandths, then why would I look for a leak that's 40,000 when I know I don't have any leaks? So it's not uncommon to have on fuel evaporation some tests that might not be complete, but the monitor will still complete. So this is a nice example of using bidirectional controls to actually run, or system test to actually run a monitor or to test the entire system.